So the first one on the circuit training is we are asked to solve. So if I solve this, and this is a tight space, you might need another sheet of paper. So 2 sine of x plus the square root of 3 equals 0. So minus square root of 3 minus square root of 3 to the sine of x equals negative root 3 divided by 2. So the sine of x equals negative root 3 over 2. So where does that occur? Well, let's see. Sine is y. So here's where our y coordinates are negative, and what's opposite root 3 over 2? That angle measure is pi over 3. But what are these actually? Well, this is pi, which is 3 pi over 3. So this angle measurement is 4 pi over 3. And this is 2 pi, which is 6 pi over 3. So this would be 5 pi over 3. So what we're going to do is we're going to go to the one that has that on the top. So here we go. And this is going to be our number 2. So find all the solutions to on the interval between 0 and pi to the equation 2 cosine squared of x equals 1. So I'll divide by 2. So the cos squared equals 1 over 2, and then we square root. So cos of x equals plus or minus, we square root the top and the bottom. Well, this is one where we're going to have to rationalize it. So times root 2 over 2. So plus or minus the square root of 2 over 2. So this is in quadrants 1 and 2. Well, here's root 2 over 2 for our x, for our cosine. And we know that that angle is pi over 4. And we just want between, in this quadrant, and between 0 and pi. So this is pi over 4. And this one is 3 pi over 4, right? Because this is 4 pi over 4, so 3 pi over 4. So now we are going to be looking for pi and 3 pi over 4. So if we do that, here's number 3. So find all solutions, okay? So it's in factored. So either the cosine of x minus 1 equals 0, or 2 cosine of x plus 1 equals 0. Well, this one's easy. The cosine of x equals 1. So that's right here. So at pi, or that's not pi, so at 0 or 2 pi. 0 or 2 pi. Let me try and erase that. Oops. Because that's the coordinate 1, 0. So this is at 0 or 2 pi. So it's every 2 pi k, because every time you go around the circle. This one, minus 1, and divide by 2. So cosine is our x. So if that's negative half, we're at 3 over 2, which means this is pi over 3. So again, if this is 3 pi over 3, so this is 2 pi over 3 plus 2 pi k, and this would be 4 pi over 3 plus 2 pi k. So now if we look for that next one, let's see, where can I find that? So 2 pi k. Here it is. Number 4, right here. All right, so if 2 plus cosine of x and g of x, what are the x points of the points of intersection? So I'm going to say 2 plus 6, the cosine of x equals 5, minus 2 minus 2. 6 cosine of x equals 3. Divide by 6. So we want where the cosine of x equals 1/2. Cosine is our x value, so here's half. root 3 over 2, so that means our angle is pi over 3. But what would this actually be? Well, in the first quadrant, it's pi over 3. And let's see, well, 2 pi is 6 pi over 3, right? Those are equivalent. So one less than that would be 5 pi over 3. All right, so we are looking for pi over 3 and 5 pi over 3. So right here. So this is number 5. So now we're solving this equation. Okay, so plus 3, tan squared of x equals 3. So the tan of x equals plus or minus the square root of 3. And again, tangent is the y over x. So is square root of 3 root 3 over 2 divided by half? Or is it half divided by root 3 over 2? Well, it's that one. And we just want 0 and pi, so that would be here and here. So again, our angle is pi over 3 again. So what is this? This is pi over 3. Again, this is 3 pi over 3, so this would be 2 pi over 3. Pi over 3 and 2 pi over 3. We'll write down below. So this is number 6. Given an inequality that describes the values of x from negative pi to pi for which they are both greater than 0. Okay, well, we could do this a couple ways. We could graph it, and we just need to graph from 0 to pi. So sine starts here. Okay, or if we were to look at our unit circle, sine is 0 in here. So where is our y value positive is right here. And then if we were to graph this next one, it starts at 1, an amplitude of 2. And then it would go down to -1. Sine starts high, mid, low. Okay, but we need to know, right? We need to know where it's greater than 0. So if I was to solve, where does the 2 cosine of x plus 1 equal 0? That's where the cosine is -1/2. And I think we did that already. So root 3 over 2. So that's pi over 3. So in this quadrant, that's actually 2 pi over 3. And in this quadrant, it is 4 pi over 3. So that's here and here, right? And we want to know when they're both greater than 0. So it would be, and if I transform this onto the other one, right? Here's our sine. So they're both greater than 0 right here. If we were to look at the cosine one on the unit circle, we want to know when it's less than -1/2. So we said that this was 2 pi over 3, and this was 4 pi over 3. So it's less than right here. So where's the only place where they're both greater than 0? We can see on the unit circle it's here, right? And that would be here. So that would be in between 2 pi over 3 and pi. So let's see if we can find that one somewhere. Oh, sorry, I messed up on that one. Oops, this was right. So we want to know when it's greater than 1/2. So that is right here, when it's greater than 1/2. So that means right here, so between 0 and 2 pi over 3. So if we go back up here, that makes this number 7. And now we can factor this. Now I don't like all the signs, so I'm going to rewrite as 8y squared. And if I do 8y squared negative 6y 1, so 8 times 1 is 8, so 8 and 1, 4 and 2, that adds to 6, so negative 4x, negative 2x, so we got 4y and 2y. Whoops, those should be y's. So minus 1, minus 1. So I have 2y minus 1 equals 0, and 4y minus 1 equals 0. So this one is y equals half. Well, that would be pi over 6. And since this is 6 pi over 6, this would be 5 pi over 6. Well, this would be add 1 divide by 4. Well, that's not a unit circle value, but we could solve it by finding the inverse. So let's see if we can find number 8 somewhere. Right here, number 8. And I wonder, did it say between 0 and pi over 2? Yep, so it wouldn't need to be that one. All right, so number 8. Find the coordinates of intersection. Okay, so where does 2 cosine squared of x equal the 3 cosine of x? Well, let's set it equal to 0 since it's a quadratic. Factor out a cosine. And then set each equal to 0. So the cosine of x equals 0. 2 cosine of x minus 3 equals 0. Well, that would be here and here. So pi over 2 and 3 pi over 2. This would be the cosine of x equals 3 over 2. Well, that one we're not going to have one because 3 over 2 is greater than 1, and our biggest one is 1. So our answer for that one, pi over 2 and 3 pi over 2, which we can find right here. So this is number 9. Given an inequality that describes the values of x for which they are both greater than 0. Okay, so let's solve this. So this is where does 2 cosine of x plus 1 equals 0? So where does the cosine of x equal negative half? So that makes this root 3 over 2. So pi over 3. So we have 2 pi over 3 and 4 pi over 3. And where does the 2 sine of x plus the square root of 3 equals 0? So sine of x equals negative root 3 over 2. So negative root 3 over 2. Well, that's pi over 3 again. So this is 4 pi over 3, and this would be 5 pi over 3. All right. So if we were to graph these from pi to negative pi, so our cosine, it's at 1, and it goes up 2 and down 2. So cosine starts high, mid, low. So here's our cosine. Our sine moved up root 3 over 2, so that's kind of a little bit above 1, and then up 2 and down 2. But sine starts in the middle, high, middle, low. Low, middle. And we want to know where they're both greater than 0. So they're both above 0 here, above 0 to right here. So what is that value when it crosses? Well, that is our sine one. So that has to be 5 pi over 3 or negative pi over 3 to where this red one crosses, so that has to be 2 pi over 3. We could also, if we wanted to take a look back at this, right, we could think of it, where is it less than, greater than 1, is all of these over here. And we wanted to know when it is greater than 0. Or, excuse me, if we would do that, that would be less than. So that would be, whoops, where was this again? So this was over here. And we wanted to know if we solved this, this would be greater than root 3 over 2, would be right here. So where are there's the overlaps would be from here over to here. So between negative pi over 3 and 2 pi over 3. Oh, and that's the one right underneath. Okay, so let's see. I'm gonna rewrite this. And let's do some factoring. So 3 times 2 is 6. So that can add to negative 7. So we'd have 3x and x minus 2 minus 1. So 3x minus 1 and x minus 2. So this would be you add 1, divide by 3, x is 1/3, x equals 2, that's bigger than 1, so that won't have 1. And this one, we just need to take that inverse. We have our side length, so what would our angle be? Oh, this was number 10. All right, so let's see, where is that one? Well, that's right here is number 11. All right, so find all solutions to the equation. So when could this equal 0? Either the sine of x would have to equal 0 or the cosine of x would have to equal 0. Well, where does that happen? Well, that's all these spots. So at every pi over 2, that happens. We're running out of them here, so let's see. Right here, so this is going to be number 12. Given an inequality that describes, all right, so let's see if I was to graph this one. Sine is at 1, amplitude of 2. Here would be pi, pi, so sine starts in the middle, high, middle, low, middle. Okay, and we want to know when it's less than 0. So it's got to be in these little spots, right? Right over here. All right, and how do we graph our tangent? Well, that was here. So tangent would be in the middle and goes up. In the middle, here's our middle, sorry, and goes up. So we want to know when they're both greater than 0. So here and that little spot right there. Oh, sine is less than 0. I read that wrong. So the tangent is greater and the sine is less. So that would be right here. And they're both negative. And that would be it, right? Where one's above and one's below. So again, we could think of this unit circle-wise. When is our tangent positive? Is here and here. When would, if we solve that, the sine of x is less than negative half? Well, let's see. This is negative half. When is it less than negative half is right here. So the only spots that they're both less than negative half would be right here. And this angle, let's see, is pi over 6. So this would be 7 pi over 6 to 3 pi over 2. But you'll look, it says from negative pi. So that's negative pi over 2. And this would be negative 5 pi over 6. So in between those values, which would lead us right here. Okay, so find all solutions. So 2 sine of x plus the square root of 2 equals 0. So if I solved for the sine of x, subtract the square root of 2, divide by 2. Ah, finally, a nice easy one. So we have negative square root of 2 over 2, which means this is pi over 4. 4 pi over 4, so that would mean 5 pi over 4. And then this is 2 pi, or 8 pi over 4. So that's 7 pi over 4. I hope we only have one left. What did this say? So find all solutions. So that is the equivalent of this one, because 7 pi over 4 is that, is negative pi over 4. So this has got to be number 14. Oh, geez. And we're ending with a doozy. Find all solutions. Okay, so if I distribute 2 plus 2 tan squared of x plus tan squared of x equals 3. So 2 plus, this would make 3 tan squared of x equals 3. Subtract 2. 3 tan squared of x equals 1. So tan squared of x equals 1/3. So tan of x would be plus or minus the square root of 1/3. So plus or minus 1 over the square root of 3. And again, I got to decide tangent of x, y over x. So is that root 3 over 2 divided by half, or half divided by root 3 over 2? Well, it's that one, and this is in all 4 quadrants. So we have half in root 3 over 2, which means this is pi over 6. So plus every pi k, and then we'd have 5 pi over 6 plus pi k, because the tangent repeats over pi. Yep, and then we're back to number 1.